So today I wanted to take an opportunity to go over your next section that you all have been working on, which is this factoring special trinomials and binomials. And I know it sounds a little odd to hear it, and it may be a little bit more difficult to just kind of get that figured out. Before I get started with that, one of the things I really want to do is write down for you all the key notes for factoring, just some things to follow when you go about factoring. So key notes of for factoring. And this can apply for pretty much all of your factoring. When you start getting into your factoring, the first thing you always want to do is see if you can find a greatest. Ooh, I can totally not spell today. Apologies. So you want to find your greatest common factor. And the reason why you always want to do that greatest common factor is if you can find one of those, you can pull it to the outside, and then it's going to make all of your factoring become a lot less complicated, and it just takes out that one layer. Okay, so you always want to see if you can factor out a greatest common factor. The second thing you always want to know is you want to decide if you can factor it further Okay, so you just want to see, can you factor it further? Like, can you use any of those methods that we've gone over thus far to break it down even further? Because that is the ultimate goal when we're working with these polynomials. And then the final thing that you really would probably want to make sure you do is check your work, okay? One of the good parts about factoring that we're learning is we can always check our work, right? So once you factored it, if you just distribute and remultiply it out, you can make sure that you've got the right answer, okay? So those are some key notes just for factoring in general. But next, we're going to go ahead and start talking about how we factor perfect square trinomials. Perfect square trinomials. Okay? And these are going to be when you can see that when you have a square on each end, okay? So, for example, if I have a squared plus 2ab plus b squared, I can see that I have a square here and a square here, which is going to lead this to become a perfect square trinomial. If I multiply a plus b times a plus b, it will factor out to be perfectly a perfect square. So I can then just write this as a plus b, all of that squared. The times that you can do this is when both of these signs are positive. So if you have a positive and a positive, then you're definitely going to want to consider and look to see, do you have a perfect square here to work with? The other time it will play into it is if you have a squared minus 2ab plus b squared, okay? Where you have this minus sign here. The only way you can get a positive sign here and a minus sign in this spot is if you're multiplying two negatives together and then combining them. So this will come out to be another perfect square, which gives us the a minus b times a minus b, which gives us our a minus b squared. Okay? So you always want to look and see, do you have a perfect square? So let's take a look at an example. If I give you the equation r squared minus 14r plus 49. The first thing you want to notice is that we have an r squared, so we have a trinomial with a square. And then we want to ask ourselves, can this 49 be a perfect square? And we know if we take the square root of 49, the square root of 49 is equal to 7. So our next question is, we have a negative 14 in here. Well, if we had a negative 7 times a negative 7 to give us this positive 49, and we combined negative 7 plus a negative 7, that will give us our negative 14r. So this shows us that we have r minus 7 times r minus 7, which is a perfect square. So we have r minus 7 squared. The reason why you always want to make sure you look for your greatest common factor is when you get to situations like this, where you have 8k cubed plus 16k squared plus 8k. So at this point in time, we can't just dive in and start factoring it, right? Because we have a cubed and we have a k. If we're working with polynomials and you have a variable down here in the spot that normally is the C spot that is normally our constant, you want to see, can we factor it out? And if you have a number that's other than 1 in our A position of our trinomial, you want to see, can you factor it out? So I'm going to look and say that 8 divides into both 8, 16, and 8, and k goes into k cubed, k squared, and k. So I can take out an 8k to start with. When I do that, 8k cubed divided by 8k gives me a k squared. 16k divided by 8k gives me a 2k. And if I have 8k divided by 8k, it gives me a plus 1. Now I have the situation where I have this special situation where we have a k squared, and we know that 1 squared is 1. So I have a perfect square. So 8k, k plus 1, k plus 1. So this is again a perfect square where we have 8k times k plus 1 squared. Another special case is when we have the difference of two squares. So if I have the difference of two squares, that is going to be where we have a squared minus b squared. I do not have a middle term. So that means I have a plus b times a minus b. The only way I can have a negative square term here, is if I have a positive times a negative. Because remember, if I have a negative times a negative, it gives me a positive. So that shows it has to be opposite terms. So this is going to be our case of the difference of two squares. So an example of that would be h squared minus 64. I can take the square root of 64 is going to be 8. So when I do the difference of my two squares, I have h plus 8 times h minus 8 to give me the difference of those two squares. Okay. Again, the key thing you want to make sure you're always remembering is factoring out your greatest common factor. You always want to take a look at that. So I'm going to go ahead and jump in here and do a couple other examples for us just to take a look at. So let me scroll down here and I'm going to work a few more examples for you just to help make sure you're good and comfortable with these. Let's do this r, if I have the problem r to the 4th minus 81 t to the 4th. Okay, there's a lot of parts to this, right? We have numerous parts to this. So the first thing we're going to notice is we have something that is able to be taken the square root of, right? And we have the negative. So this looks to me like it is going to be an example of the difference of two squares. Okay, so if I take the square root of 81, I know that's going to be 9. If I take the square root of t to the 4th, that is going to be our t squared. So if I'm doing the difference of two squares, I'm going to break this down, and I have r to the 4th plus, or sorry, excuse me, r squared plus 9t squared times r squared minus 9t squared. So we have the difference, but we're not done at this stage because we still have a perfect square and a perfect square, a perfect square, and a perfect square. This section, this with the negative rt or negative t squared, is very similar to what we had in this situation. So this is going to be the difference of two squares. So I'm going to start by factoring this part out. So I have an r plus and I have an r minus. So I have r plus, r minus. The square root of 9 is going to be 3, and the square root of t squared gives me a t. So I have 3t. Then I'm going to look at this right here. And I have to ask myself, can I factor that any further? And the answer is going to be no, because this is a positive sign. And we only have two ways that we can get a positive square, right? The only way we can get this term here to be positive is if we either multiply a negative times a negative or positive times a positive. And because that would have the same sign, it would give us a third term that would show up in here in the middle. So therefore, we cannot factor this any further. So we have an RT plus 9t squared. And this is our complete answer for this special trinomial. Okay. Let's go ahead and take a look at another example, shall we? So let's just do this where we have a squared minus 4 over 49. So we have a fraction thrown in there, but that's no problem because we know how to work with fractions. We know that we have a negative number here. So this, we're looking, and we know that 4 is a perfect square. 2 times 2 is 4. And 49 is a perfect square. 7 times 7 is 49. Because this is a negative sign, we know this is going to be the difference of two squares. So I'm going to have a plus 2 over 7 times a minus 2 over 7. Hopefully this tutorial has helped you a bit more, get a little more comfortable with these special factorings. Remember, if you have any questions, please always feel free to reach out. Have a great day.